It's a heavy burden being a man of science.
I know what you mean, Jimmy. That's why I decided early on to sabotage my highly scientific mind with cartoons and sugar.
Get strong.
Basic chemistry. Before we jump into water chemistry and macromolecules, let's review what we learned in 8th grade. So we all have heard about atoms and specifically elements that we find on that thing called the periodic table. If we look at this element, its symbol is C, which means it is carbon. The number underneath, that's usually a decimal, that's how much it weighs. Technically it's its atomic mass, but I like to think about it like that. And then the number over top is the atomic number or the number of protons it has. So let's dive in and look at it, what it actually looks like. If I draw carbon, I notice that it has 6 protons. They have a positive charge, but if I keep all those protons together, I need something in between them as a buffer. So I add something called a neutron. It's about the same size, but it does not have a charge. It's neutral. If I had all these positives together, they would want to push away from each other, so I need neutrons in between to keep them from repelling each other. To counterbalance the positive charge, you notice the little specks on the screen. Those are electrons. They're itty bitty and they have a negative charge. So I want you to look at the size of these, and of course it's the scale, but tell me which is heavier. Is it the blue and green dots, or is it the little tiny yellow dot? Well, of course we would say that it's the blue and green dots. So this is where the atomic mass comes from. If I add the neutrons and the protons together, it will tell me how much this element weighs. And also tell me which element is if I look at the number of protons. So if I add a proton to this picture, now we're talking about nitrogen instead of carbon. So let's take that away and let's do some scenarios. Let's say I have an extra neutron. If I have an extra neutron, it's something called an isotope. What if I have an extra electron? If I have an extra electron, I call it an ion. Now let's talk about bonding. There are really 3 main types of bonds. We're going to use 2 in this class. The first 2 that I'm going to mention here are very strong bonds. The first one that we're going to talk about is if I have an element like carbon, that's him with a smiley face, and he wants to share his electrons. We call this a covalent bond. Co means together, valence, the electron he's sharing. So they're sharing their electrons together. Notice that is a solid line for his arm, so it's a strong bond. The next type of bond that we're going to talk about, we don't use this one as much in biology, but it's called an ionic bond. This is where it's still a strong bond. Notice his arm's a solid line, and he's just saying, take my electrons. I'm not going to give them back. You just take them. This is ionic bond. This usually happens between a metal and a non-metal. And this is where electrons are transferred, kind of like you transfer money into somebody else's account. They're not going to transfer them. So this is more of a very permanent bond. It's very hard to break. Salt is one of these. You don't see salt falling apart in your cabinet. It's bonded together pretty well, and it's between a metal and a non-metal. Good news for us, we do not use this in bio very often. You will use it in chemistry. The bond that we like to talk about, that we love the most, this is called a hydrogen bond. Hydrogen bonds are in between water and our DNA, and this occurs between a hydrogen and an oxygen of another molecule. So it's not the same molecule. It's not the hydrogen connected to the oxygen in individual waters. Notice the dotted line that's occurring, that's the hydrogen bond. Hydrogen bonds are important because they're like little magnets, and they can pop together and pop apart at any time. We call them weak attractions. This is good because if water was not bonded with that dotted line, if it was a solid line and you jumped in a swimming pool, it would not break, which means that you would not fall in the water. You would just hit the water and land. Think about magnets, little bitty magnets that pop apart, put back together. Also think of it as like a conversation. That's still a bond, but that conversation can be broken at any time. And those are the basics of bonding. Next, we'll learn about water.
Of an eagle. She had a VCR but wanted a DVD, and the god sent munchkins to hypnotize her water skis. So she took her peanut butter sandwich for a walk. The